Okay, this is the start of a new unit. We're going to be doing a lot of logic and reasoning now, so it's going to be a little different. We're going to start out by titling these notes Section 2.1, and we're going to start with something called Inductive Reasoning. So if anybody wants to be a lawyer, then this is going to be a chapter that you're going to want to pay attention to, because there's a lot of things that come up in this chapter that would come back up if you ever tried to be an attorney or some kind of litigator. So inductive reasoning, I'll start out by defining that. Inductive reasoning is when several examples form a pattern. So when several examples form a pattern, and you assume that pattern will continue. Okay, so when several examples form a pattern, and you assume that pattern will continue. And we're going to jump right into the easiest example I can think of. So here's our example. If I write out a list of numbers, and I write 1, 3, 5, 7, and then blank, blank. And your job is to determine what the next two numbers in the pattern are. Now bear with me, I'm sure you know what the answer is. But what you would do to figure this out if you didn't just know the answer is you would look at the examples and try to determine what kind of pattern they form. And what you'll see here is that the pattern we see is that we add 2 each time. So we go up by 2. So our pattern that we're observing is that we add 2. So we're going to assume that the pattern will continue. And that's how we know we're doing something inductively. So I'm going to assume this pattern continues and say that this will be 9 plus 2 more, and this will be 11. That's an example of inductive reasoning. And now at the bottom, underneath there, I'm going to write something, a statement about what I think happened. And I'm going to say each number is 2 more than the number before it. Okay, so this statement that I wrote here, this is called something. This is a word we need to learn. This is a conjecture. A conjecture is a statement you believe to be true based on inductive reasoning. Okay, so that's something that we want to keep track of, and we want to remember what that word means, because in your notes and your homework and your assignments and your everything we do, you're going to be asked to write a conjecture. So a conjecture is a statement that you believe to be true based on your assumption that a pattern will continue. So a couple of things about conjectures now. Conjectures are either true or false. Okay, if I took one look at all my students the first day of class and said every one of these kids is going to fail geometry, they don't have a chance of passing it, that would be a conjecture that I made, and it might be based off of some pattern and assumptions that I made, but it would be a false conjecture, right? Because somebody's going to pass, I hope. So when we say that a conjecture is true or false, if it's true, that means it is always true. Okay? Always true. Every single scenario, every single time, no matter what happens, It's always true. If a conjecture is false, that means that it's not true at least once. And when it's not true, that's called a counterexample. And we're going to practice this here right now. So we're going to do a nice example. And we're going to say that we have a conjecture. So this is a statement that is assumed to be true based on a pattern of inductive reasoning that somebody's made. So the statement will say, two complementary angles are not congruent. Okay, so take a second and read that again and think about what that says. This is a geometry problem, so we're talking about geometry. We're not going to be always talking about things that we think are true or false in the real world. We're going to talk more specifically about geometry, but this has applications in the real world, especially for attorneys. Anybody that has to use logic, has to use reasoning, computer programmers especially do this. So when we see this conjecture, two complementary angles are not congruent. Well, we're either going to say if this is true or if this is false. So if it's true, that means that it's always true. That means every two complementary angles will not be congruent. If it's false, I just need to come up with one set of complementary angles. Remember, that means adds up to 90. So I can think of 45 degrees and 45 degrees. I could have two angles that are 45 degrees each. They would add up to 90, right? But this says that they have to be not congruent. So this is false, and this is my counterexample. So if you're going to prove that something's false, you have to provide the counterexample. You can't just say, no, that's not true. You've got to prove it. You've got to give a legitimate counterexample as to why it's not true. Let's do another one real quick. Last one and we're done. So here's our conjecture. Real simple. This is going to be an algebra one. X squared is greater than or equal to x. So what this is saying is that no matter what number I pick here for x squared, saying any number, anything I pick, if I square it, it's always going to be bigger than what I started with. Okay, now there's a lot of numbers out there, so you can't just say, no, that's not true, or okay, I believe that, that's true. You got to try a couple examples. So you want to come up with a pattern or a systemic way of solving these. So I'm going to start with an obvious number to try. I'm going to try x equals 1. Well, that means x squared also equals 1. Well, that works because that's equal. So I'm going to go bigger. I'm going to go to a bigger number now. I'm going to try x equals 2. Well, x squared equals 4. So again, still true, right, as far as these examples go. So I'm going to go really big, right, because nobody's going to trick me. I'm going big. So I'm going to do 100. Well, when I do 100 squared, I get 10,000. So somebody's probably thinking, oh man, this idiot, he keeps trying numbers. He needs to go the other way. He keeps trying big numbers. He needs to go small numbers. So I'm going to go down into the negatives. So I'm going to try x equals -1. Well, when I square it, -1 times -1 is +1. Well, that's still bigger. That worked again. So I want to try to think of a number that when I square it, it's going to get smaller. Well, -2. So I square -2. Well, that's +4. So I'm not getting anywhere. The number that I'm looking for is a fraction, like 1/2. Nothing said it couldn't be 1/2. So I try fractions. When I square that, remember, 1/2 times 1/2 equals 1/4. So this is 1/4. So for this conjecture, I can say that it's false when x equals 1/2. I could have picked any fraction that was less than 1. I could have picked 1/3 or 1/4 or whatever. But anyways, that's a real quick introduction to inductive reasoning and, more importantly, making a conjecture and saying whether it's true or false.